In today's video, I'm going to talk about a recommendation system. And towards the end of the video, I'm going to talk about how Netflix does it so that it will recommend the TV shows and movies that you really like. And it's at a high level, but it'll give you a good idea of how to accomplish that. So first, we're going to talk about different types of recommendation system. So there is content-based or collaborative filtering. Content-based meaning that you have to know the user very well. You have to know what the user is interested in, maybe demographics information about a user, or for a product, it has to know what is this product exactly used for, what category is it fall in. So you have to know your user and product both really well to be able to create a content-based recommendation system. So on the other side, you have collaborative filtering, which meaning no features really labeled across your product or across your user. You're pretty much clustering users and items based on their similarity, or you can do factorization, where it's like a giant matrix, and you try to put in like different parameters, such as like number of features in each product or in each user, and the weight of each feature or product. So then it will be more ambiguously defined, but it will be a lot easier for people who want to recommend things that you don't really know well of for your user and your product. So even under collaborative filtering, there are two different types. So one is the one I talked about, that's briefly talked about, which is memory based, and it's kind of using based on the item to item similarity or user to user similarity. So you're recommending people based on whoever bought this product also bought that product. So that's item to item similarity. Or if you looked at the other way, which is looking at the user, looking at how these users behave similarly. So then if this user is similar to this group of users and they're likely to buy this item, then you'll recommend this item to these users. And you usually can also do it based on k-nearest neighbors clustering, so that you have all the items and all the users together, and you kind of group them by towards the item level or the user level. The downside of using this method is that it's harder to scale because you have to do like a very high dimensional clustering. And then on the other side, we have model based. So you can do matrix factorization, which you have to assign very ambiguous numbers, like number of features you want to include. You can try 5 or 10 or 15 or even more, but you wouldn't really know which one would be the best unless you actually calculate all the metrics at the end and then kind of do a comparison. But make sure that when you put in your parameters, like try to put in like further away, like don't put something like 8 and 9. Those two are probably harder to tell apart. And also you have to assign a weight to your features, which is also kind of ambiguous, but you can try out different parameters to see how it looks different. And then there's also the other way, which is singular vector decomposition. It's pretty much breaking down the giant metrics into three smaller metrics. It has to involve more linear algebra, and if you're interested in that, you can look into how singular vector decomposition works in recommendation. And to start out as a beginner, we typically walk through this process of, how do we build this recommendation system with one metric that you have in mind, either if their user purchased certain item or if they leave certain star ratings. So it really depends on what data you have available to gather. And that way, and then deciding which metric would be the best metric for your recommendation system to use. And then the second thing is that, since we talked about different models and different ways of building a recommendation system, then we need to really know, do we know all the features that are related to the users and products? And we have to make sure that we actually know all the features very well. Because if we have, certain bias towards the users or make certain assumptions that we make towards users or products, the recommendation system can be really biased if that's what's ended up happening. So based on that, if you think you know your feature of your users and products super well, you can use a content-based recommendation system. Or if you think you're not 100% sure, you feel like you can potentially introduce some biases, then you can use collaborative filtering. And what actually Netflix did is they actually use a hybrid model, which is that they actually manually label some of the content, but also use collaborative filtering. And we're going to go into that in more detail in a later section. So, high level pros and cons on content based versus collaborative filtering. Content based is, it's harder to know all your users and products super well, unless you have been working in this industry for years and years. So that's a con for using content base. But a pro for using content base is that even if the user is super new, they just created an account, you will have the user being labeled. And if the product, so the thing about collaborative filtering is that they tend to favor products that has been out longer, has more reviews, or has more people has been purchased more often, versus a new product wouldn't be recommended as much. So the upside of using content base is that new user and new products will all have a chance of being recommended because you know all the features very well, and that's what you're recommending based on. Well, collaborative filtering is that you're introducing less bias because you're not really telling the model, what features is each user like or is each product like. So you're not introducing bias. But then the downside of what I said earlier, you're favoring more popular and more higher demand products and versus users that's new, you would likely to not have any information about the user and you wouldn't know what to recommend them other than giving them like a very generic recommendation based on the next step in terms of thinking about what metric you should include in your recommendation system. There are many ways of thinking about this. So imagine, Amazon, they have so many star ratings for each product, and they can you really use that data for their recommendation system versus other businesses. If they don't really sell the product directly or they don't really have a star rating system, then this really doesn't apply, right? But then on the other side, you can also look at other data like usage data, how long have they been using a product, or how much time they spend on the products. That can also tell you how much the person likes the product, right? And the other thing is like engagement data are like based on what have they purchased. Maybe you have an e-commerce site and you can see what this user has purchased or what this person has viewed certain products, and you can recommend them based on their view or their purchase, which will be also very helpful. And also the last thing you want to consider is like, do you have to recommend the same product twice? For example, like if you like for recommending books, for example, would you want to recommend the same book twice? Less likely that you want to do that because they already bought the book, and why would you want to recommend them the same book? But there might be other use cases such as TV shows or movies that it's something that you would want to watch again after maybe certain years or certain months, or some people just really like watching the same show or same content over and over again because they really enjoy the show. So those are the things that you probably need to consider when you want to populate this matrix or this giant recommendation model that you're trying to build. So now I'm gonna give you a quick overview of how Netflix does their recommendation system on their TV show or movies. So then you will, continue watching and binge watching their show as much as possible, and you're also willing to stay on the platform longer, and also to be willing to pay their monthly subscription fee. So if you haven't noticed that Netflix actually has every row by genre, and how does that work? Because in our recommendation system, if we talked about like matrix factorization, it actually doesn't, don't really know the products really well. So it's actually a hybrid model that Netflix uses between content based versus collaborative filtering. So content based is that you have to know your user or product very well, and that's what they did is that they manually labeled the genre for each movie and TV show. That's the content based part, but they still run everything through collaborative filtering, so you're reducing a bias towards the users and uh, and your product. So that's the advantage of using both is that you can make sure that if someone is very scared of horror movies, then even if the one of the horror movie can be ranked very high for this person, but this person does not like horror movies, then you will probably eliminate that for this user, right? And so this is kind of how the giant matrix look like in a matrix is that you have a user and you have a product on the top. So you can see that Amy and Andy are more similar because they both really like oranges, where Alice does not like oranges. So it seems like Amy and Andy are more similar people, and that's how you will use a user similarity. Quickly cover what I just talked about. So I first talked about content based versus collaborative filtering, and how content based is that you have to know your product and know your user very well. And I also talked about pros and cons about using them, about the biases, and also the computation power that you will have to use for these models. And then we also talked about, what kind of metrics to use for your recommendation system. Not every single business has the same metrics because the star rating isn't necessarily applicable to all business and all products. And lastly, I talked about how Netflix uses a hybrid model, which combines content based and collaborative filtering to create the best, recommendation that will help you